is very important. I think the first two representation you are very easy to understand, right? Then let's see the key point of the VLAN. Pay attention about the Ethernet. Ethernet is a SIGMA-CD communication mechanism. And about the layer 2 switch, we only talked before. They will follow the traffic according to the MAC address, but they cannot discard the broadcast message. So if we want to limit the broadcast flooding, we can use a technology we call it VLAN. VLAN is virtual LAN, virtual local area network technology. Okay. Oh, cool. Yes. You know the full name of the SIGMA-CD. Okay, if you want to know the detail, you also can follow us YouTube video. I also explain the detail how to work of the SIGMA-CD. And after this course, I hope you can understand the working principle of VLAN and the main configuration of the VLAN. This one is very important because in your network, I think everyone already configures the VLAN. So first, let's see the working principle. Why we use the VLAN? In this scenario, our terminal, we have lots of departments, right? One for technology department and another one for the finance department. In this scenario, if the technology department send out the broadcast message, and what's the range? When layer 2 receive broadcast, because this is a broadcast message, so I will flood. The flooding means I will send all the interface except the receiving interface. Then the layer 2 switch also will flood again to another layer 2. Finally, layer 2 switch will flood to all the interface. So if in the time, for example, if we have 400 terminals, they will send out the broadcast frame at the same time. In this link, lots of resources will follow the broadcast message, but maybe it's not useful. For example, the first technology send out the broadcast package maybe is ARP. I want to find the third computer. What's your MAC address? If for some scenario only the third terminal can receive this message, the other link, like this link, or these devices will not receive this message again, right? Because finally I will discard the message. So how to limit the broadcast domain? Someone maybe say we can use router. We can use layer 3 switch. Because about the layer 3 port will not flood the broadcast message. But it's too expensive, right? So router to isolate, this also is a solution. Then to router will skip it, right? And another one more cheap and more convenient is a VLAN. For example, in this scenario, if we have two departments within the same layer 2 switch, we cannot use one router here, right? That means maybe about the access layer, we have to deploy the router, and the core layer, we also have to deploy the router in order to avoid the broadcast domain. So this one is too expensive. And another one, if we use a VLAN, the VLAN is very convenient because this is a logical configuration. And if we use the VLAN in our network, this is unlimited of the physical location and be flexible, built logical grouping. For example, maybe we have different terminal and in different flow within the same department. Then we can use the blue one to indicate the technology department, use the VLAN 10, but the yellow one use the VLAN 20. Although they may be in the same flow, maybe in different flow, it doesn't matter. This is a logical technology. So this switch for the traffic not only consider about the MAC address, we also have to consider what's your VLAN. I only for the VLAN information in the same VLAN ID. So this is the main principle. And the next step, we have to know why the switch will know the VLAN. And what's the different operation if we add the VLAN tag. So if now one switch directly connect with the terminals, and some terminal in the VLAN 10, some terminal in the VLAN 20, and when the switch receives this information, I will add a number, and this number we call is tag, and this tag will show the switch. For example, now I send a message from the left one to the right one, and the destination MAC address maybe is OF. This is a broadcast message. But now we add the tag. We add the number is the number 10. So although you have to flag, but we limit the range. Only flag in the same tag. This we call is VLAN tag, VLAN 10. So we can limit the range. If the message without the VLAN, this one we call is standard Ethernet frame. Pay attention. Normally, the terminal, your computer, maybe your laptop, or maybe some router, send out the message. This is a standard Ethernet frame. They don't know what means VLAN and what's the mean of the 10 or 20. But switch know. And if we add the VLAN on the switch, on the frame, then this one we call is an Ethernet frame with IEEE 802.1q. 802.1q is the protocol of the VLAN. That's why maybe in your VLAN configuration, you also see some command like 802.1q. This is the command you add the VLAN information. So, what's the information on the VLAN tag? We have lots of information. The first is a TP ID. The TP ID is a tag protocol identifier. The number is fixed. Value is 8100. That means this value will tell with switch. Now the message carries the VLAN information. The second part we call is TCI, tag controller information. And about this part, we have three information. The first is the VLAN ID. The VLAN ID is 12 bits long, and it indicates the VID. The range is from 0 to 4095. But pay attention, the available range is from 1 to 4094 because the VLAN 0 and 4095 is reserved. That's why when you create the VLAN, you can create VLAN 1, VLAN 10, VLAN 1000. You cannot create VLAN 5000 because we limit the range, right? And the second one for the priority, it has 3 bits long. Indicates a priority level. Maybe you use some QoS, quality of service, in your network, and you want to distinguish differently a message. We can have different priority. So you can use this part to indicate. And the next part is a CFI, 1 bit. Indicates the bus time of Ethernet, FDDI, or token ring. About this part, on this training, you only have to focus on VLAN ID is enough, 12 bits long. And later, let's see how to work about the switch if we add the VLAN information. First one, we say about the terminal send out the message. This is a standard Ethernet message, right? Without any VLAN information. So when the terminal send out the standard Ethernet, and then the switch will receive. When the interface receives, I will add a VLAN tag. And there is a question. Add a VLAN 10 or 20 or 30 or the other VLAN. Depends on your configuration. Depends on this interface, you give the default VLAN. What's the default VLAN? We also call this as a PVLAN. Okay, this is a PVLAN, default VLAN. And this is the first part. When I receive the message, when I send out the message, we have to get the VLAN because the other side also is a terminal. The terminal cannot recognize what's the meaning of the 10. So I have to delete the 10 and then send to the terminal. So about the terminal, don't know we add the VLAN or not, or what's the VLAN information. So this is the key point. Of the terminal, we only send out non-tagging standard Ethernet frame. Also the same operation of the VLAN 20. Okay, so this is a single switch of the VLAN tag. If everyone connects with the same switch. And in the switch, we also give a special name for this switch interface. This interface we call is access point. And about this access point, only allows the default VLAN to pass and receive and send in the data frame for one VLAN. That means about the first interface. About this interface, if we are ready to use the command to give the VLAN 10, and this interface only can deal with the message with VLAN 10. If I receive the VLAN 20, or some switch hope I to forward the VLAN 20, this interface cannot work. Only can deal with one VLAN. Pay attention about this part. Generally, this interface will connect with customer equipment like our terminal, like our computer, like our laptop, something like this. And also maybe connect with router, we also will use the access point. So this is a scenario, right? And if all the terminal connect with one switch, access point is enough. But more scenario will like this one. We will cross the switch VLAN. That means same VLAN terminal will located in different switches. And between switches, we only have one link for the traffic. So in this scenario, we need a solution. Why we need a new solution? For example, now about the VLAN 10, the switch 1. First, the interface will be used for VLAN 10, right? And then when I receive the message, I will add the VLAN 10. If the interface 24 will also divide the interface about VLAN 10, so the message will be sent out. Of course, maybe we will delete the VLAN. And then the left switch receive it and will forward the message according to the 10. So in this scenario, if we have only access switch is access point, this also can work. But at the same time, if VLAN 20 also sends the message out, and then the interface receive add the VLAN 20, and there is question is how to deal with the VLAN 10, the VLAN 20. Can we give some solution? If we divide the interface 24 for VLAN 10, the 24 interface can forward the VLAN 20 or not. According to the principle of access point, it cannot, right? Because access point only can deal with one VLAN. Yes? So in this scenario, we need a new interface to forward the VLAN 10 and the VLAN 20 at the same time. So this is our requirement. And how to solve this problem? We will use a new port. This port we call is trunk port. And about the trunk port, we can allow multiple VLAN to pass through and can receive and send the data frame for multiple VLANs. The Ethernet frame without the tag for the default VLAN. That means now we can make the interface connect with terminal. This type is access point. And the PVID is 10. And another one to connect with VLAN 20, the PVID is 20. And about the interface of the switch, trunk port, the PVID is 20. And also allows the VLAN 10 and the 20 pass. But pay attention, any type, access type or trunk type, the PVID only can be 1. So about the access, PVID is 10. I only will receive untagged information. I will add the VLAN 10. And when I send out the message with the VLAN 10, I will delete. About the trunk port, what's the function of the PVID? When I send out the message out, I will compare with my PVID. If the PVID is same, I will let the message carry VLAN and send out. If the PVID is different, the PVID is different, I will let the message carry the VLAN and send out. But if the PVID is same, I will delete the tag and then to send the message out. So this is a function of the PVID. But about the trunk port, I can allow multiple VLAN pass-through. Okay, so this is a function. If we use the trunk, now the VLAN 10 sends a message to switch A. Switch A will add the VLAN 10. And then send the message out, carry the VLAN 10. And when the switch receives the information, I also will receive it and send out from the first interface, because this interface allows the VLAN 10 pass through. This is a VLAN 10 communication. And about the VLAN 20, send out to the switch, I will add the VLAN 20. And about this interface, also only can be forwarded from the gigabit 24, because the gigabit 1 only working for VLAN 10. And when I send out, I will compare with my PVID. The PVID is same. So I will delete the VLAN. And then when the switch B receives the message, because this without VLAN information, I also will add the PVID 20. Then the message will be sent out from the gigabit 2 to the destination. So this is a function of the trunk port. And about the trunk port, generally used to connect between switches. So pay attention about this one. So this is the first part of the working principle. And then let's see the VLAN configuration. How to do the configuration. And here I only show you the command configuration, not about the GUI page. If we want to configure the step, configure the VLAN, the first one we have to create the VLAN. And then we have to configure the different interface type. For example, the access interface. This interface usually connects with your terminal. And another one configures the trunk interface. If you have multiple switches connect with each other, and in your network you have multiple VLANs. You have to create the trunk, connect with the switch. And the third one you can check. So about the VLAN configuration is very easy. The first one, how to do the configuration. On the config mount, create the VLAN 10, and also you can give the name. This is the option mode. That means if you don't add the name, also this also can work. But if you add the name, it's easy for us to do the operation and meetings. And the VLAN 20 name for finance. And if you have interface connect with terminal, then you have to configure the access point. The command is you have to enter the interface at first, and then set the port mode to become access, and give the PVID. This is the access VLAN ID. For example, now you can directly enter multiple interface, the range interface, to make all the configuration in two interfaces at the same time. And switch the mode to become access, and the VLAN is VLAN 10. And enter the interface 3 and give the VLAN is 20. Why we skip the step 2, right? Switch the mode is 20. Depends on your devices. Some devices, the default mode is access. So you don't need to add the mode access again. You can direct it to give the PVID. And if you configure the interface of the trunk, of course, you also have to enter the interface, then switch the mode to become trunk, and switch the trunk native VLAN. This native VLAN is a PVID VLAN. And then the very important one is to do the control behavior. For example, now I make this interface to become trunk. But if you want this trunk interface to follow the multiple VLAN, you also have to add the behavior here. Otherwise, the trunk interface cannot. And another one, pay attention, is some devices, the default behavior is permit VLAN all. That means you don't need to add the behavior again. By default, I allow every VLAN pass through. But in your real network, with suggestions which VLAN exists in your network, you allow this VLAN all. As you allow this VLAN, it's enough. It's more security for your network. Okay, so this is a suggestion. And the first one, we have to enter the interface and switch the mode to become trunk. And enter this single interface to allow VLAN remove 1 to 4094. That means to delete everything, right? And only allow the VLAN 10 and 20 pass through. So after we do these two commands, your interface to 0 only can allow the VLAN 10 and 20 pass through. And pay attention, if you don't give the native VLAN, if you don't use the step 3 command, we will use the default native VLAN. This VLAN is VLAN 1. And another one, pay attention about this part. Only allow your service VLAN pass through. It's more security. And after we do the configuration, then we can use this command to view or delete VLAN. Delete VLAN means no VLAN and give the VLAN ID. Pay attention. In the switch, by default, VLAN 1 exists, and all the interface built to VLAN 1. And VLAN 1 cannot be deleted. Pay attention about this part. So maybe you can use VLAN 1, or maybe you can you don't use VLAN 1. It doesn't matter, but you cannot delete VLAN 1. But if you create VLAN 10, you also can delete VLAN 10. Okay, and then the stator is static. Static means you use a command to create the VLAN. Of course, in our network, we can use some protocol to dynamic learn VLAN. Okay, about this technology, we will not talk about here. And also, we will have the interface to tell you which interface can allow the VLAN pass through. So this is the basic configuration of the VLAN. And here is an example. And we have the switch A and the switch B, and VLAN 10 and VLAN 20, right? And now if we hope the same VLAN can communicate with each other, what's the configuration here? About the switch A, we have to create a VLAN 10 at first, and add the interface into the VLAN 10. This also is another way to do the configuration of access interface. You can directly add the interface into the VLAN. And the VLAN 20 add the interface, or maybe you enter the interface to change the access VLAN, the same result. Then about the interface 24, you have to switch the mode to become trunk and allow the VLAN to become 10 and 20. Because about switch B, we have the same interface to connect with each other. The configuration is same. It's easy, right? And here, some practice. The first one, which of the following are characteristic of the VLAN? Which are character of the VLAN? Here is a multi-choice. ABC. Any other option? Or only A? The answer is A, B, C, and D. Okay. So maybe the option A, B, C is easy for us to understand, right? This is a reason why we want to use a VLAN in our network. And the option D maybe is a little complex because we don't talk about the detail here. We talk the interface type of access and chunk. And pay attention. By default, in the VLAN, about the layer 2 switch, only the same VLAN can directly communicate with each other. If we want to do the communication between different VLANs, we have to use layer 3 device because we have to use the router, use the routing information. By default, VLAN 10 message cannot directly to forward to VLAN 20. So the option D is correct. About the option D, maybe when we talk about the routing part, we will see the communication between different VLAN. This one is a little difficult for us, maybe. Which of the following hosts can communicate with each other? Pay attention about these two, switch 1 and switch 2. Connect with the terminal or the interface is access interface. And the VLAN is VLAN 10, VLAN 20, VLAN 30, and the right one for VLAN 10, VLAN 20. The different one is for switch. Switch 1, the interface is the chunk. But the native VLAN is 30. The switch 2, interface type is chunk. But the native VLAN is 20. So if we add this communication here, who can communicate with each other? Communicate with each other means if I send the message out, I can reply. I can get the reply. So what's the correct answer? If this one you can get the correct answer, I think you already know everything of the VLAN of the access and the chunk. This is a multiple choice. A and B. No more. Maybe we can analyze it. Okay. First, I think PC1 can communicate with PC4. It's easy for us, right? Option A is correct. Let's see the process. When PC1 sends out the message to port 1, we will add the VLAN is VLAN 10. And about the VLAN 10 cannot be sent out of the second interface, right? Because the port 2, yes, the port 2 only can deal with VLAN 20, and the port 3 also cannot. But this port 4, can be forwarded out because here is a chunk interface, and the native VLAN is 30. 10 and 30 is different, so we will send the message out, carry the VLAN 10. When I receive the message, this message carries the VLAN tag is VLAN 10, and then later the message will be sent out of the first interface, and the VLAN 10 will be deleted because this interface also belongs to VLAN 10. The same process of the 4 to 1. So option A is correct. Then let's see the option, the PC2. About the PC2, send the message to the second interface. We will add the VLAN is VLAN 20. And then when the switch 1 receives this message, I will send the message out. Before we send out, we will compare the message with the net VLAN. It's different, so I will directly send to switch 2. And when switch 2 receives this message, because this one carries the message, so I will directly receive. And only the port 2 can deal with the message, delete the VLAN 20, and send the message out to PC5. So this step is correct. Let's see the comeback. When PC5 sends the message out, I will add the VLAN is VLAN 20. And when I send the message out, the net VLAN is same with me, so I will delete the VLAN 20. So in this process, the VLAN without the tag to switch 1. And switch 1 will add the net VLAN 30. Because this VLAN is 30, so only the port 3 can deal with the message. And then send the message out. So that means PC5 sends the message out. Only the PC3 can receive. PC2 cannot, right? And we also have to check PC3 sends the message PC5 can receive or not. When PC3 sends to switch 1, I will add the VLAN is VLAN 30. When I send the message out, the 30 is same with my net VLAN. And then I will send the message to switch 2 without VLAN tag. And the switch 2 receive it, I will add a VLAN 20. And the VLAN 20 is same with port 2. So I will delete the VLAN and then send to PC5. That means PC2 can send to the message to 5, but PC5 cannot give reply to PC2. But 3 and 5 can. So the answer is option A and C. And I see someone give me the message, the native VLAN is different in one link. Pay attention. This topology only is used for us to do the practice, to understand the native VLAN function better. In the real network, in the same link, the native VLAN usually will be same. Because some vendor, if the native VLAN is different, the trunk interface cannot work. But in some vendor, they only give you a warning. A warning the native VLAN is different, but still can work. But here, I only show you the example to let you know the native VLAN better of the trunk. So it's clear for you about this part? No more question? If no more question, let's have a brief summary of the VLAN for you. First, what's the function of VLAN? Pay attention. Someone say the VLAN within different, if the devices within different VLAN, we cannot directly communicate with each other. Why we use VLAN? So you have to remember the function of VLAN. We only want to limit the range of the broadcast domain in the network to reduce the waste of the resources. If in your network, your bandwidth is big enough, and if everyone send out the broadcast message at the same time, your resources also is enough. So you make everyone in the same VLAN also can work. But if you want to limit the range, to limit the broadcast domain, to let the broadcast packets within the short time, the small range, you can use a VLAN. If everyone in the same VLAN, there is no loop, also can work, it doesn't matter. And in the switch, we explain two types of VLAN interface. One is access interface and another one for trunk. Pay attention about access, only can deal with one VLAN. So usually connect with the terminal. But about the trunk, we can allow multiple VLAN communicate with each other. So usually we will use the between the devices, the switch devices, and pay attention about the function of the native VLAN of the trunk. And here I do a table for you, one for the access and another for the trunk, how to deal with the message. We divide the process to become receive the message or send out the message. When we receive the message, pay attention. If we receive the message without the tag, that means this is a standard VLAN. I will add the native VLAN. This is a PVLAN. Access in the trunk, only one PVLAN. But if we receive the message with the tag about the access, if the with the VLAN ID is same with my configuration of the native VLAN, I will receive it and then do the next step. But if the VLAN is different, I will direct it to discard it. And about the trunk, if I receive the VLAN ID is same with the native VLAN, I will receive this package. If the VLAN is different with the native VLAN, I have to check the permission list. Only receive the VLAN in the list, otherwise I will discard. So this is a process to receive the message. And another one, when I send out the message about the access, I will delete the VLAN tag. And about the trunk, two scenarios. If the VLAN ID is same with the native VLAN, I will delete and send out. But it's different. I will let the message carry the VLAN information and send out. So this is the information of the VLAN. So today we talk about the three presentations, right? One for IP address, one for layer 2 switch working principle, and another one for VLAN. Any question here? Maybe now we can discuss something. Any question? No more question? So I think maybe everyone already knows this information, right? No more question? Ready? Yes. We also have the hybrid ports, but this is not today's topic. The hybrid port you can think is combine access and trunk together. For example, 1 and 2 want to communicate with each other. 3 and 2 also want to communicate with each other, but we hope 1 and 3 cannot. In this scenario, maybe we will use a hybrid port. But usually we will use the access and the trunk is enough. Yeah, we also have some high complex technology like the super VLAN, like the sub VLAN. It's more complex. But this is a basic training, so we don't contain about this technology. So maybe in your network, you use a hybrid VLAN and the super VLAN. No more, right? So I think maybe everyone already know it. And I have another two questions for you. First one, what's my name? Do you remember it? Yes. Okay. I hope this one is the most important of the first day 6. I am Emily, okay? If you choose another answer, I will be very sad. Thank you, guys. Okay. And another one. Do you still remember what are the tomorrow topic? Do you remember? Yes. Good. So I think these guys already know every sentence today I talk. And tomorrow we will also have the technology for the layer 2, one for link aggregation, one for STP, and the third one we will begin talk something of the layer 3. Okay, so this one, my name is Emily, and tomorrow our topic will talk about the STP and the link aggregation, and the time is same with today at 2 o'clock p.m. to 5 o'clock p.m. and the GTM +8. Thank you guys. It doesn't matter after all training later, I will send this training video to each email. It doesn't matter. And thank you guys for today's training. And I hope you can join tomorrow at the same time. My points maybe at the last days later. Thank you guys. Bye bye.